Hi everyone, my name's Daniel and today we'll be learning about waves. More specifically, we'll go through a definition of what a wave is, we will look at some of the terminology that we use to describe waves, and then we'll look at the different types of waves. So, a wave is a disturbance that transfers energy from one place to another without transferring matter. It's an energy transfer that doesn't bring physical material with it. And depending on the type of wave, it can travel through solid, liquid, or gaseous states of matter. Now, there are lots of different waves. So to describe them, we use some simple terminology that we can apply to all types of waves. So if we look at this first diagram here that I'll just put some highlighter on, we have displacement in meters on the y-axis, and we've got time in seconds on the x-axis. We start with amplitude. Amplitude, if we highlight that, amplitude is the maximum displacement from a position of rest. So the amplitude in this case is given by this red arrow. It's as far as you can get from where you started. So in this case, our rest position is the x-axis, so our amplitude is the maximum displacement from the x-axis. You might have noticed that this red arrow isn't the only place of maximum amplitude. This point here is also maximum amplitude, as is here, and this point here. All of these are points of maximum amplitude. If you were asked in an exam to label maximum amplitude, you'd get marks for labeling all of them. Now, let's clean this up, and then we'll talk about wavelength. So, next, the wavelength is the distance between two consecutive points on the wave. Now, the way I like to think of consecutive points is peaks and troughs. I like to think trough to trough and peak to peak. These are our consecutive points. A peak may also be referred to as a crest. It just means sort of the highest point on the wave as opposed to the lowest point. So we can see here we have one trough, we have another trough, and the wavelength between them. Similarly, we have one crest and another crest, and we have our wavelength in between. And these two lines are the same length. Now, if you clean that up a little bit more just before we talk about frequency. So, the frequency refers to the number of waves that pass through a point per second, and this is measured in hertz. So we've got our time on the x-axis of this graph. If say this point here marked 1 second, we just need to wait for it to load in on the screen. There we go. This is 1 second here. We have one full wave, two full waves. 2 full waves in our 1 second period means we have a frequency of 2. We can then use the frequency to calculate a period for the wave. This tells us how long it takes one complete wave to pass by a given point, and this is given by 1 divided by the frequency. Moving on, we can look at this next diagram and learn a bit about the different types of wave. So there's 2 broad classifications of wave. There are longitudinal waves, where the motion of the disturbance is parallel to the direction of travel. You may see this referred to as direction of propagation. Propagation just means travel. So if someone says a wave propagates in this direction, it means it moves in this direction. In a longitudinal wave, the motion is parallel to propagation. In a transverse wave, which is the second type, it's perpendicular. So if we look at the longitudinal wave to start with, just highlight that, we can see our red particle here. We see as the wave moves, the particle moves back and forth, and once the whole wave has passed, it will settle back at its initial point. So the motion is parallel. For the transverse wave, we can see, if we look at this red arrow here, as the wave passes through, we see the particle moves up and down. The propagation is horizontal, but the particle motion is vertical. And that is what we mean by perpendicular. So this is a transverse wave, and this is the second type of wave. A key distinction: longitudinal waves can pass through all states of matter. Transverse waves can only pass through solids and gases. If you want to challenge yourself, look into the discovery of Earth's liquid outer core, because this was done using this property of transverse waves. We found that we could measure longitudinal waves that passed from one side of the Earth completely through to the other, but there weren't the corresponding transverse waves. These were missing, and they were missing because there's a liquid layer that was stopping this. So if you want to challenge yourself, look into that. But that is beyond the specification of GCSE. You don't need to know that. But if you want to stretch yourself, go for it. So to recap, hopefully you now have a better understanding of waves and the different types. So a wave is a disturbance that carries energy but not material. And we can describe it in terms of amplitude, wavelength, and frequency, with the main two types being longitudinal and transverse.